Okay. Months ago, we did an episode that was related to Unix history. We talked about Unix and Linux. That was a part one of our journey through the Unix operating systems. Now we do the volume 2, which is going to be about many other different versions of Unix that are apart from the original Unixes that came out in the 60s, 70s, and the Linux, which became a thing afterwards. So today we're going to talk about the next HBUX, sunos, Solaris, PyX, whatever. That doesn't really matter. With most of them, we do have some experiences. With some of them, we don't. But we've seen them in action or followed their development and how they got integrated into other products. So let's have a discussion about those. Again, this is the new episode of That IT Show podcast. Let's roll the intro and start the conversation. Okay. Which one you want to start talking about?
I want to start talking about neither one.
Of course.
What I want to talk about is the Unix philosophy.
Mm-hmm.
And I want to talk, since in this universe, we just finished talking about the OS2. So I want In this universe. So I want to mention some things that are pretty important when it comes to design of operating systems.
Okay.
And this is that the operating system can be designed, or
what a strange idea.
It can be organically grown, as Windows has usually done.
Like a plant?
Yes. So basically, you throw ideas at the developers and then just throw it in the operating system as soon as the operating system is running. And I think this is one of those things that we don't remember, that what Microsoft did didn't have an idea when it started. It was started as a spin-off of another people's idea. Then they got people
multiple ideas.
Yes. Then they got the people who did VMS.
Okay.
And they created a mess out of everything that was on the table.
Okay.
And the Unix, when it was initially designed, so in the 69, being 1969, this was the operating system that was intended to be a completely new operating system that would be independent of the hardware.
Okay.
But the first idea wasn't even an operating system. They wanted to create a game.
Really?
Yes.
Okay, I didn't know this.
So basically, Thomson and Ritchie tried to do a game on the PDP-7.
Oh, I did really read about this.
And they were trying to do it in assembly. And then they tried to say, okay, this is going to be something that requires the things that are required by a game. So you need to wait to talk to the hardware, you need to wait to display things, you need to wait to get input from the user, and so on and so on and so on. So they created a different, what would be called modules today, but were called functions back way then, that enabled you to talk to the computer.
Okay.
And then they turned it into Unix version 1 that was done in 1971.
Okay.
And this was the idea that had a background. And the reason why I'm talking about the background is because when they started the design, they decided to keep it to certain standards, certain ideas, and to try to create everything that is designed in the Unix to keep it uniform. And by uniform, I mean to conform to certain ideas. Some of the ideas, you can take a look at them. There are different interpretations of those, but some of them are the same wherever you look. So first thing is that you are going to have one program that is going to do one thing. It's going to do it well. Or sometimes it is called keep it simple and stupid, or keep it simple and running, whatever. But the idea is that if you have an application, for example, ls, that is used to display the files on the file system, it can have as many options as it wants to, but they should be related to displaying the files on the file system. It shouldn't be also archiver, I don't know, able to open the archive, save the archive, display files, and so on and so on. This is the thing that is happening in Windows. As soon as you have a working application, suddenly it becomes bloatware because the developer doesn't want to stop. He wants to continue adding features to his application. And in Unix, this is usually frowned upon. People say, okay, is your application right now the ideal way to display the number of files, whatever? Yes, stop. Good example is WC. Word count.
Okay.
Word count is able to count the words,
the lines, the bytes, the characters.
Letters, characters. That's it. It doesn't try to do anything else other than this. The next thing that they decided to do is that the files and the applications are going to communicate between each other using text.
Okay.
So if your file, if your application is going to output something, it shouldn't be formatted too much.
Okay.
And the idea is that even if you're doing the format, you need to be as uniform as possible, so that you enable other people to use their own programs, and you are able to forward the data that your application is outputting to the other applications, so that you can actually do something in the other application, because the applications are going to be piped together. So the result of one is going to be piped into another.
Yes, but not as objects.
Yes, not as objects, straight text, because everything else is a string. So everything produces a string, so you can actually count on text being text. You always should expect that your application should be able to output something to another application.
Okay.
And also you should be thinking about using your application as something that can accept the input of another application.
Okay.
Or the output of another application. So you should be able to accept text inputs.
Okay.
Not only from the person, but also from other applications.
Okay.
Because this design enables you to chain different applications one after the other and create something. Also, you should build and test every week. You should break things, you should try things, and if something works, you should make it happen as soon as possible. So they decided against testing, doing continuous.
CI/CD?
The idea is continuous integration is okay, but they were against keeping applications in alpha and beta test for months.
Okay.
They said, okay, if something needs to be changed, change it. If you remember back then when Linux had a problem with A out and then elf, when they decided to change the design or the internal structure of the binary, they just did it.
Yep, and both worked out of the box.
Yes, and this was one of those things where Windows would have tremendous problems trying to do this. .com is still a valid application in Windows.
Okay.
And this is one of those things when backwards compatibility doesn't make any sense.
A lot of people would frown upon that, but yes.
Also, when you're doing something, create tools. Create your own scripts, then use your scripts to do things, because you want to build on your work, and then you want to avoid repeating your work as much as possible.
Okay.
Because you're going to be a better application designer in this. You're going to be a better system architect and so on. Because you are creating your own tools, you know how to do these things. So you don't want to waste time on redoing things that you already did. You should be just upgrading your knowledge and creating new things. Files should be stored as text if possible. So all the data should be stored in text. If you need to do something in binary, okay, but if possible, do it in text. Okay. And this is the reason why we have XML. And we have different versions of, yes, but it enables you to create a structure that is basically a text file.
Okay.
And you can embed images, you can embed other things, but you're also storing them as text files. So you don't risk trying to store it on a file system that doesn't understand how to store binary.
Okay.
Then portability over efficiency. If your application needs to be written in such a way that it's going to be slower, and at the same time you want to run it on different architectures, do the application so it is slow, but it runs.
Okay.
So that everything can be compiled. And this was extremely interesting back way then, because the Unix wasn't designed for a particular architecture. They started designing on one architecture. They switched their architectures a couple of times during the first 10 years. And the idea was that the Unix should be running on all of them at the same time, if possible. So they were trying to rebuild things. While maintaining compatibility. And the only way to maintain compatibility is to be wise when you're designing application inside. And the last thing is that that is important, and that was designed way back then, is that you shouldn't be creating everything by yourself from the scratch. You should be trying to build based on libraries and object files and everything else that you already have. So you should be able to talk to your colleagues, you should be able to reuse their code and try to create something new based on the old code.
Hence open source.
I think it was a prototype what would later become an open source.
Okay.
The reason why they did it, because they didn't want to redo everything from scratch every time they started to do something. So the application would more or less depend on the operating system doing basic things, talking to the hardware, talking to the processor, talking to the display, getting input, getting output, and so on. And this is one of those things where, as long as we don't understand the how things were working back way then, you don't realize why this was important.
Okay.
Because the first version of Unix included something things like file system. Before that, you stored information to the disk by just referencing the sectors.
Okay.
So you needed a file system. You needed a way to create processes. You needed something that is going to be handling processes. They decided that this is going to be a multi-user system. So they decided you're going to be able to create separate regions of memory that are going to run separate processes at the same time. So it all that took enormous amount of
what we call design.
And enormous amount of great engineering.
Yeah, forethought.
Because you didn't have anything to build upon. You were starting from scratch.
Yep.
And this is the reason why I think that the 60s or the late 60s are probably the most formative years when it comes to operating systems.
I agree.
Because what you had back way then was you had operating systems that were specifically tailored for one specific computer, not architecture, but computer. Then you had the idea of Unix that was trying to get cross-compatibility done. And also you had a different kind of operating system that was designed with a particular function in mind. And I'm talking about Apollo guidance computer and the derivatives that came after it.
Okay.
Because
special use case computers.
Yes, but these special use case computers are in use up until today.
Yeah.
And I was just a couple of days ago, I was watching a documentary that was trying to explain how Apollo guidance computer was important for the history of the computing, because it was one of the most the one about NASA and fly-by-wire. The thing is that probably one of the things why we have today's design in the airplane industry is the direct result of what NASA and MIT did when they designed the computer. And you must remember that they designed the computer from 1962-63 to 1967, and we are still using it, 60 years later? And the ideas are still fresh.
Because they are a product of a lot of forethought and good design.
Also good optimization, because they understood where the problems lay, and they didn't try to do what developers are more inclined to do today, and this is to say, okay, my design is bad, but if I wait enough, I'm going to solve the problem by sheer hardware power.
Agreed. Absolutely agreed. One of the cancers of computer science nowadays, or the application development in particular. Yeah, you're on the money.
I'm just going to put one thing out there, and this is when they were designing the Apollo guidance computer, they understood that they're going to have extremely limited amount of memory that's going to be read-only memory. They're going to have extremely limited memory that's going to be able to write and to keep some information
and
in
it was unreliable as well. So had to design for that too on a hardware level.
They had to design on the hardware level without actually knowing how reliable it's going to be, because they didn't know if the computer, when it passed through the belts surrounding the Earth, is the radiation going to interfere with the computer's functioning. So they were trying to design something that they didn't know, they didn't have the entire risk calculation about, and then they have extreme amount of unknowns that couldn't be checked before the computer itself had to function. So what they did is something that would be that is completely out of the question today. They tried to, or they did create parts of the memory that could be patched into. So they could overlap parts of the memory based on what they needed, so that they could actually replace the read-only memory with memory that could be written later, and it could be patched through based on your current requisites for the mission that they were doing. Also, they had another problem, and this problem is completely out of the question today, and this is the problem where you had to create the application that would work months, sometimes years before it would be used, and you couldn't make an error.
Yeah, it had to be extremely precise.
Because the application, it had to be woven into physical memory. So you couldn't change it later. You could, but then you had to use those patches that I was mentioning later.
Wasn't Apollo based on some kind of a Unixoid RTOS or something like that?
No, it was a completely different idea. The idea was that it had an executive, so it had a what we call kernel today. It had processes that had to run. It was able to run concurrent. I think it was 6 or 7 processes concurrently. They had priorities, and if the computer wasn't able to run on all of those, it would be able to reset itself and then continue running.
Yeah.
And this is what saved a couple of missions, including the first one, the first landing on the moon, because the computer kept resetting itself. But since the design was so good, it was able to continue running. And the idea of a computer being at the same time, a computer is setting itself at the same time as running normally, is completely off by today's standards.
Yeah, it's impossible to do. Actually, to kind of patch into what you were saying, so good intro, very good idea. Wasn't aware that you were going to go this way. But I want to patch into a thought that you had, in which you voiced a couple of minutes ago, which is that everything needed to be compatible, various different architectures, and it needed to run without initial hassle, and that a lot of, let's say, forethought was given to the design of application from a perspective of compatibility. And I have a completely opposite example of that from that era, and era afterwards, actually, and it is Unix-based.
Yes.
If you remember when we started going to our old college, we were using sunos Solaris machines for labs and for our student things and whatnot. We had 3 or 4 of them. One of them was managed by students. And at least a couple of times when I was there, it had to be reinstalled. Okay.
Yes.
How did the reinstallation of sunos Solaris of those generations work? Just for the short explanation. You use the CD, from which you deployed the kernel and the basic set of utilities, which included CC specifically.
Yes.
Then you used CC to compile GCC, and then you use GCC and all of the libraries that you can then compile with it to compile everything else.
Yes.
Okay? Which took days.
Yes.
You see that that's a hassle. It's completely against the philosophy that you said. I'm mentioning it as an outlier, not to diminish your principles, which were completely correct.
Yes, but it's not that they weren't following the Unix philosophy. It was the result.
Extreme implementation of it.
No, but it was the result of the amount of work that was already done by the time the Solaris went into market. Because if you remember, back way then when Linux came out, the first versions of Linux weren't able to do kernel modules, so you had to recompile the kernel when you started.
Yes.
And this was just the thing that you needed to do because nobody expected you to get binaries by themselves. Normal distribution of applications was done in C. You got source files and that was it. And this was the result of when the Unix itself was created. It was an extremely small and compact piece of code written in assembly. Then they created a programming language. So the C came later because they wanted a high-level language in order to be able to do something in Unix. And then
to make it easier for themselves as well,
yes,
while not sacrificing too much.
And then they created the manuals, because this is also important, because an operating system and a completely new programming language without any support in any manual doesn't make sense.
Yes.
And then they were able to create and distribute the version that was actually commercial.
Okay.
And this is Unix 6. It took them 6 versions in order to get to that point. And also, there is a version 7 that introduced different shells.
Okay.
So that the I/O library and the user interface and everything else was standardized, and it was decoupled from the operating system.
Yep.
So these were different milestones, but if you think about it, those milestones were important because they defined different things that you had to do on your computer. They were also trying to solve the problems that they had, because, for example, using a shell makes sense only if you have a problem because you have multiple users, and your multiple users require different settings inside their own environment.
Or they use different shells, settings and shell, let's say, functionalities of different shells to program shell scripts.
Yes,
because declaration of variables and some other things were a little bit different.
Yes, but the environment is the problem.
Yeah.
Because if you want to have an environment that is separate from mine, we need to have separate sessions. Once you start to have separate sessions, it makes sense to create something called a shell, because this is your shell, this is my shell, then you can have different sessions for a single user and so on.
Okay.
So these things didn't come up as somebody actually sat down and designed it, but it came up organically, but then it got
upgraded.
Then it got included into the entire structure. Unlike some other operating systems that basically just slap it on and try to solve this problem in the user space, because this had to be integrated into the kernel space, and this was something that this is something that actually designed what the kernel and user space were.
Okay.
So the Unix was, from my perspective, the most interesting technologically from 69 to 80. Then later versions were just big upgrades, but upgrades. First Unixes were technology advancements that were amazing. Then it just stayed I wouldn't say the same, but the technology advancements stopped being so big. They just did incremental upgrades, and this was
logical.
This is logical, and I think that the next big thing that happened in the Unix world was when the graphical interface was introduced.
Okay, X11 and whatnot. Okay. So let's say that the first one that I remember using for a significant portion of time was actually sunos/Solaris, because we had it in college. We also had the University Academic Center, which had a whole bunch of them too. We got access to them by being students in the, being educated in the public space. And that's where personally I cut my teeth as a Unix, let's say, administrator. I switched to Linux, let's say 6 months later or whatnot after that. I remember Solaris for a couple of reasons, and that memory has stuck with me afterwards, and I have a couple of them actually in my garage, the Ultras, that I would like to make them run again because they deserve it. First thing that, generally speaking, got to me, or that I really remember about Solaris, is that although we reinstalled it over the course of 7 years on those student computers twice, it was actually very robust. It worked really well, it didn't crash, and it handled oftentimes like dozens and dozens of users. And we're talking about mid-90s now, when we didn't have multi-core CPUs or the CPU power that we had nowadays. People leaving screens, downloading, using graphical interfaces because it used to have that as well. But back way then, graphical user interfaces were standardized in another way, in which they were using XMDCP. So you were basically had a central server from which you loaded the graphical user interface, and you had a UI terminal, which was GUI based, that loaded the environment from there after you logged in. And we had 8 of those terminals in the lobby of the college, and we used those for years, connected to the very same one server. So those graphical user interfaces took a heck of a lot of CPU time and especially memory. And of course, network was being used a lot for it, but it worked rather well.
Yes, but the idea that if you think about today's world, the idea of having an operating system that is going to be stable and running for days and months while being used by 20 or 30 users at the same time.
And harassed 24/7.
Those users are going to be wildly different in the amount of knowledge they have about using the operating system. So they're going to create different problems. For example, I had a colleague of mine who was trying to learn how to program in C. And he wanted to create a client-server application that is going to be based on sockets and so on and so on.
Okay.
What he did is that he created a server application that is going to listen to the socket. And what he did is he said, while 0, wait on socket.
Okay, not the best idea in the world.
And this actually didn't crash the entire system because the system itself was able to recover from it and say, okay, this is what the user did. This is stupid. All the users are going to get limited access to the processor, but the operating system has its own priorities, so it's going to continue running. Even today, you can break some of the operating systems today if you do something like this. And this is one of those things where the design was above all. The design was able to keep up with the users and with the technical knowledge or lack of technical knowledge of the user.
It's not only that. Back way then, while you're on the topic of that, PAM modules were heavily used for these sorts of circumstances, and you could set PAM limits.
Yes.
Module can be used for this, and they were heavily used on these machines. For those of you who are not familiar with the idea, the concept is very simple. By using system modules, you could say this user can, for example, have this amount of context being CPU time,
cycles,
processes, amount of memory, whatever, and that user cannot get more. Which means that even back way then, we're talking again, mid-90s, you could partition the system into multiple different sub-environments which didn't crash with one another. Basically, that's a quality of service mechanism if you look at it from today's perspective. And that worked beautifully. That worked really well. And Linux has the same principle, same modules, same idea for configuration, which was evolved afterwards. But still, I mean, we're talking, again, mid-90s, 30 years ago, we already had that. And hence the reason why those machines, which were abused 24/7, literally, because the college was open 24/7, those machines almost never crashed. That just didn't happen all that
yes,
much.
the crash was something. Also, we need to take into consideration things like the hardware. The disks were
SCSI, all of them.
they were SCSI, but at the same time they were slow compared to any standard of today. But they worked. Because the SCSI was designed in such a way that the disk could work.
Imagine if today you try to, let's say you go to eBay, buy a computer of, let's say, PC from that era, which would be, let's say, 1995, that would be let's say, 486 to Pentium era. Installing Linux on top of it, logging 20, 30 users on, and then let them run Chrome, every single one of them. I mean, back way then, Netscape Navigator, who cares? I mean, the machine would crash instantly. It would be slow to a halt in a second.
Yes, but the thing was that way back then, also the applications understood that they're going to be run in extreme multi-user environments, and they didn't try to act as they like they own the entire hardware.
It's not only that. I would say, again, system configuration was done in a correct way, but also remember that we are talking about the RISC CPUs. In those days, RISC CPUs were the bomb.
Yes.
But more about that in another episode. I wasn't actually leading to that conclusion. It just popped into my mind that Spark CPUs, all of them were RISCs.
Let me now just go into another thing that I liked about the early Unix systems, and this was the switch to graphical user interface.
Okay.
Because it actually came in the 80s. during the end of the 60s, when the Unix was just getting started, during the entire 70s, the entire decade, the systems were text-based.
Yes.
Then graphical interfaces came into light, and the thing that happened is that different companies that were producing Unixes, or they had their own flavor of Unix, they introduced their own version of a graphical interface.
Okay.
The most common one was the one that was done, that is called the X, done by MIT and then redone by guys at DEC and so on. And this was one of the things that also redefined the framework on how a computer should look like. Because when we're talking about object operating systems and we need to also understand that the concept of a window wasn't known back then. It had to be invented. Concept of the mouse had to be invented. There was also a separate war going on called the connector conspiracy, if you remember it.
Yes.
When different vendors were trying to do the same thing using wildly different connectors, because they were trying to sell their own hardware and make other people pay for it.
Vendor lock-in, basically.
Vendor lock-in, and so it came down to the thing that you couldn't use a keyboard from one system to on another, or you couldn't use a monitor on different systems, you couldn't use a mouse on different systems, you couldn't use any of the external hardware that is normally compatible with everything else. And this is one thing. Then people realized that they need to do something, and when the 90s came in, they started trying to create compatible systems between each other. And the reason is because the companies, especially the universities, started or suddenly got themselves stuck with different architectures, different computers from different eras. And some of them were intended to be used on some project, some intended to be used on another project. And the idea was to ensure intercompatibility. If you had, I don't know, a DEC, a Sun, and an IBM, you had to have a common factor in order to be able to work on all of those, while at the same time connected to a single terminal.
Yeah.
And this had to be done in some way. So first, telnet and text-based terminals were created, and then the same thing happened with the graphical terminals. And then the different environments came. So the Visual User Environment, the CDE, the Enlightenment, the KDE, GNOME, and so on and so on and so on.
Yeah.
So different things happened.
Actually, there were a couple of commercial versions of X Windows as well, Metro Accelerated, but that was more on Linux.
Yes, and the interesting thing is that X, or the graphical interface, lived to this day.
Yeah.
The Wayland tried to do away with X, but X is still alive. You can even get implementations for it on the regular Windows, and you can run X applications from a Unix server on your Windows for free, basically.
Hence XDMCP protocol.
Yes. So the thing is
fantastic.
But this came out of standardization and trying to stick to the rules. And this is one of those things where I don't understand why Microsoft chose the other way to do it.
Let me interject with something of a story of personal nature, professional nature, actually. The first job that I did before you and I became less than competitors by working for different magazines, I mean permanent job, was for a company that does simulation tools for a variety of automotive companies, for suspension, for whatnot. They're based here in Zagreb. Their environment was based around a buttload of Unix systems, but not one of them only. We had a bunch of Linuxes, we had a bunch of HPUXs, we had a bunch of Sun machines, and my personal favorite, we had a bunch of Silicon Graphics machines. We had a mutual authentication system, LDAP-based. LDAP existed back in 2003. It existed way before then as well. So everybody could log into any of these systems and use whatever they wanted in the shell First point, easily, secure shell, telnet, whatever. And second point, you could basically, they had Linux-based PCs for development. You log in, you do, let's say, X remote session to any one of these different systems. We could easily start any application from any of those and do basically remote, what Microsoft does with remote app nowadays, and has been doing for the past whatever amount of years. XDMCP existed way before that. But the beauty of that was that you could have a simulation tool from Silicon Graphics loaded on your screen. You could have another different simulation tool from HPUX loaded on your screen on the same computer. They worked beautifully. I very much remember that because I was aware of XDMCP way before that and used it extensively. But that's the usage model that we had with those Solaris terminals as well. But it was the first time that I saw it outside of the academic environment being implemented in a real production environment by a company doing some serious business. And that also stuck with me for all of those years, 20 years afterwards, we're talking now, because we were very happy with that environment and the way in which it was easy to manage and administer. We had, myself and one other guy, we were doing the administration and system engineering, and it was working beautifully. I mean, no problems whatsoever.
And this is why I was so when I became old enough to realize that the main difference between what X did and what Microsoft did with this remote desktop protocol. When I realized the differences, it was completely puzzling to me. Why did Microsoft, at the time when they were actually expecting that the amount of work done remotely on the machines is going to be much more interesting to people, why did they choose a protocol that is way less optimized than what X was? It didn't make sense to me. It doesn't make sense to me.
They reinvented the wheel yet again.
But they didn't reinvent the wheel. The wheel was it was basically
square wheel.
Square. Because what they did is they decided that they're going to send bitmaps over the network, and they are going to create something that is going to be bandwidth limited by bandwidth. And X was able to function over extremely limited
network bandwidth.
Network bandwidth, extremely limited links, because it was designed when those links were normal.
I actually used X when I in 1995, tail end of 1995, when I started using Linux. I quickly understood the way in which the graphical terminals work, and I started using the X applications from those servers that we had in college, from my Linux computer at home, being logged in via an analog modem.
Yes, it would work.
It was slow to start to get the application via network, but after that.
And this is one of those
just
things
reminded me of that. That was kick-ass.
When it doesn't make sense, what happened later. But let's go back to the Unix, because you have your own. I want just to put the timeline into perspective and try to understand where the Unix came from.
Yeah,
it came from the idea of people who were trying to create something that would enable them to run a game. So this is a pretty normal motivation for people way back then, because people wanted to play on hardware that was expensive.
Yeah. Okay, so I started our discussion about Solaris and sunos. We talked about some of the memories that we have of using that, and sunos and Solaris afterwards were very successful in especially in one horizontal market, which was universities.
Yes.
It was super popular all over the world. Our college was one amongst thousands of them.
Solaris was way back then was basically a synonym for the internet.
And not only that, afterwards it was developed to trusted Solaris, and it was used by a variety of military services and whatnot prior to
the only other vendor that came close to it was DEC.
OSF and stuff like that.
Yes, but the digital
Unix. Okay.
Basically, big digital.
Actually, while we were on the topic of that, did you have a chance to use any of those digital Unixes?
Not for a while, and not for too long.
Okay.
So I have limited knowledge and limited memories to connect to those.
Okay, I have loads. as I was lucky enough to use them. First and foremost, if you remember back in the days of early internet in Croatia, when our national telecom started offering internet services, they also had, they created one Unix machine that was available to the public, which you could use through a text menu.
David?
Huh?
David?
No. It was called something else. It was OSF based, OSF1 based.
Okay.
I used that. I didn't have the account, but a couple of my colleagues and companies that I worked for as a side gig did. So I had a chance to play with this. Actually, the guy who did that and managed that in our Croatian Telecom later on became my student for loads of Linux courses, which was funny as hell. Digital Unix, though, I used that one heavily. I was lucky enough when I got to second year of college. You remember, in second year of our college included electronics 1 and 2. After I passed those 2 exams, the department that handles those courses got a huge donation by Digital, which was my first introduction to the amazing world of Digital Alpha. Later models, which were much more, let's say, much faster and much better done visually, hardware-wise, speed-wise, whatever. So I had one of the professors selected me and my best friend, who passed away sadly a couple of years ago, to manage those systems as a part of the department's idea of starting to do simulation work for various chips and whatnots. That's what electronics was all about. So I spent the better part of the next 2 years working on a dual boot system based on multiple disks. The first boot was Digital Unix. The other one was, we had a Linux version for Digital Alpha back then, which worked really well. I think there at some point I installed Red Hat on it as well. I think Red Hat had some early versions of their Linux prior to commercialization of Red Hat that worked on Alpha. So I have vivid memories of using those systems. They were amazing pieces of hardware, and the Digital Unix was the bomb. It worked very well, excellent UI. Loads of engineering applications were done for Digital Unix as a platform and for Alpha as the underlying hardware platform. There were quite a few supported accelerators even back then for those things. And we were drawing chips in that and compiling chips, all of the things that people nowadays do when they're doing that, in various simulation tools. So, yeah, the Digital Unix was a really good product.
Yes, and I think that what we are trying to say here is that we need to understand that the circumstances of the market way back then dictated that you could actually tell that what companies were trying to do, they were trying to create something that would be
applicable for certain use cases?
No. I wouldn't say applicable. I would say competitive in pricing when you compared price per seat for a person who would be doing something, because the personal computers were just coming into view.
Yeah,
they weren't popular up until 1981, 82. When the market exploded with ZX Spectrum, with different 602 based computers and so on, Schneider's, Atari's and so on. But the companies that were creating Unixes and created big systems started to form an image, probably somewhere in the subconscious, that they are going to be competing with those small machines. So they had to create, or they had to break down the price per user for a company. So they were trying to compete on the small computer market with machines that didn't have or had enough power to power hundreds of users, and they had that had and could be used over the terminals.
I would say that that's exactly the reason why Sun Microsystems existed. Exactly that metaphor, because they were heavily present in the academic market with their hardware and software, and they were the workstation type of computers and servers. They did not have personal computers per se back in those days, 90s, 2000s. Exactly in that respect, those machines were used as either workstations for engineers to do something, or programmers as well, or they were used as servers to handle certain infrastructure. It was the same with Digital Unix and the Alpha systems and HPUX for HP workstations and servers and many other let's say, different platforms that were present back then. Every single company tried to carve out a piece of market for themselves and played on that market heavily. Sun for workstation servers, mostly HPX played at the same market and whatnot, but Sun Microsystems was quite successful with it, although they were super expensive and quite. Wait a second. And the second part of that was integration with additional products. I saw with my own two eyes what it means to have a digital Unix machine based on Alpha hooked up to a Tektronix oscilloscope and various other components, which was available back then. We're talking, this is prior 2000. This is 1998, 99. So there were other types of ecosystems built around those products that didn't necessarily just involve some kind of a specific framework for, I don't know, doing a application that's going to do word processing. It was much more involved than that and much more integrated than that, even back then.
But you, when you said that Sun was expensive, it was, but it was nothing compared to IBM.
Yeah, I know. And that's what they played on.
Because Sun was considered a cheap alternative to IBM.
Yeah.
It was the cost was tens and hundreds of thousands of dollars, but IBM was costing in millions of dollars.
Yeah.
Also, IBM was pushing heavily with the mainframes.
They still are doing that.
But yes, they're still doing it, but the market of the mainframes is more or less the same as it was way back then when they said that the entire world is going to be needing not more than 7 computers or whatever.
Sure.
Now the world doesn't need more than a couple of hundred of mainframes because the mainframes are
for running everything critical.
Yes, they are important for things that were interesting, but IBM didn't position itself well when it came to servers.
Same thing happened to HP with HPUX. Exactly the same thing. They went in the wrong direction, targeted more, I would say, a little bit more towards vendor lock-in than towards many other aspects of the market. Same thing at the end of the day happened to Sun Microsystems prior to being sold to blah, 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 and then Oracle. So that's actually a testament to the market, which evaluated all of those options, took them for a while, and then saw that also the PC market went in the other direction to be available to everybody, and started grading those systems, workstation, server market systems, on a similar scale, which brought compatibility back to the fore.
Now, let's just, before we finish, because we are going to be finishing...
we still have 10-15 minutes.
Yes, but before we finish, because this is going to take us 10 to 15 minutes to start.
Okay.
We haven't mentioned one big elephant in the room.
BSD?
No, VMS.
VMS, okay.
We forgot the DEC was, or we didn't forget, but the DEC had its own backline, and it had VMS that was interesting. Okay, later it was interesting because it was running on the Alpha, but it was also interesting because it was the only viable alternative to commercial systems when it came to big distributed systems.
Okay.
You had a terminal, you could run either Unix or VMS, and that was it, unless you were running something that IBM brought to the market on the mainframe market, and they had a couple of things that you could run. But the thing was that VMS was in itself also an extremely interesting operating system.
As we are about to find out soon enough.
Yes.
Okay, I agree. I never had the privilege of working on VMS, I'm afraid. That's something that I'm hoping that I'm going to rectify soon enough with some of the next episodes that we are going to do. But yes, you're completely correct. And VAXs and other architectures that used VMS are super important. And, of course, the Alpha.
Yes, but the VAX, or the servers and the mobile servers, because I also have one of those, I'm going to show it in one of the episodes, were something that was interesting by itself because it enabled even smaller companies to run concurrent time-sharing systems. And this was more or less two different types of competing at the same time. Either you try to do dumb terminals and some kind of Unix VMS timeshare,
Okay.
Or you try to do smart terminals. Okay, let's not call them dumb, but they weren't but client computers that would then be connected into networks.
Thin clients or something like that, kind of.
Or an IBM PC. And then you didn't have the networking, but you had enough power on your desktop to be able to do basic tasks. So either you were trying to do everything extremely connected with the specifically dumb terminal, so the terminal couldn't do anything by itself, or you had enough power, but then the networking part wouldn't work as good.
Okay. Just to mention, and it's a good thing that you mentioned VMS, because yes, I forgot about it, my bad. VMS still exists.
Yes.
OpenVMS is still being actively used by loads of people, because at the end of the day, this is the digital legacy and whatnot. While we're on the subject of digital, and this is going to be a topic of our next episode, if I forgot to mention something in one of our previous episodes, the fact that OS2 failed pisses me off heavily, okay? Nowhere near as much as I'm pissed off about the fact that Alpha failed. And for reasons that are going to be apparent in some of the future episodes. VMS is like an outlier in that story, in a sense. And that's good, because it's a good platform to do a variety of different things on.
The thing is that failure today is something that is sometimes hard to pinpoint.
Correct.
I'm going to just quickly step into today's world and ask you with this. Has the Raspberry Pi failed?
No.
But what is it used for?
I know. So it didn't fail in terms of being still on the market, but it failed in every other aspect because it's way too expensive for its initial promise.
Okay, it wasn't that expensive back then, but the other thing is that if you want to do anything useful with the Raspberry Pi, you suddenly are faced with the idea of either it not being available,
correct,
when you need it.
Yep.
And then
for
at
the past couple of years, it's been horror.
Yes, and at the same time, the scarcity of the Raspberry Pi is because everybody wants to buy it.
Okay.
But I don't see that many people actually using it.
Okay.
I see a lot of stuff being done as a hobby on it, but let's call it a small office, home office production environment are not based on Raspberry Pis, because still the PCs are cheaper when it comes to everything else. So did the Raspberry Pi fail or not?
Still think not, but I understand where you're going with this.
And this is one of the things, it's hard to say if has the Chrome failed? Has the Firefox failed? Firefox is right now losing its market share left and right. Chrome is more or less one of the worst browsers out there.
And yet we still use them.
Yes, and this is one of those things. We have come to a point where you can have a product that's being used by hundreds of millions of people, and it can be considered a failure. And also you can have a product that's going to be used by tens of millions of people, and then being considered a wild success.
I would also, to your point, add one other fact. Because of the way in which these things that we talked about today were designed from the ground up, be it in hardware, be it in software, because it was much more codependent design than what we do today, which is the strength of those products. I would say that all of the things that we mentioned, all of the OSs and all of the platforms that we mentioned as well, the echoes of those products, both in hardware and software, are still felt all the way through the IT industry. That means that those things were good products. And most of you started with the principles of Unix and whatnot. Those principles still stand.
Yes, and this is one of those things where I still cannot get over what PowerShell did to the scripting.
Oh, come on, don't go back to Microsoft. It's not the topic.
Yes, but I just, when somebody talks about the philosophy, the streams, the text files, the input and output, and then Microsoft comes barging in like an elephant in the glass shop and says, okay, we are going to be doing this differently. How differently? We don't know, but we are going to be doing this differently.
Okay. Can I steer our conversation in another direction?
No, I'm just going to stop with bashing Microsoft, but just to be noted.
Okay. BSD.
BSD is one of those rare things where I completely fail to understand why are people still
raison d'être.
No raison d'être, but the why the people are still behind it, while at the same time understand why people are still behind it.
Yeah, it's a conundrum.
As people love it.
Religiously, oftentimes.
FreeBSD is great in some particular usage scenarios.
Like?
Routers.
Storage. ZFS.
I would say routers.
Okay.
But I think that the way they're handling the network is much better than what was happening in the Linux.
Okay, but
Linux
they are coming closer together,
yes,
generally speaking. Okay.
And this is one of the main reasons is because people in Linux have enough developers so that they can address the different things that they screwed up the first
Many
time
years
around.
ago.
The first time around, or the second time around, or the third time around.
Third or
when
fourth,
it
or
comes
15th.
with the TCP stack.
Yeah, okay.
But the thing is that FreeBSD has its own place, but the reason why it has its own place is because first the users are fanatical. And then the developers
so are the Amiga users and Commodore C64 and Amstrad users and Sinclair users. So what's your point?
But the last Spectrum or C64 game came out this year, so I don't see...
My point exactly.
So, but FreeBSD is one of those things where you can have different spin-offs that are of the original project that are going to make a lot of sense for a particular group of users.
I mean, there are people who are still actively developing games for C64.
I can understand that.
Of course, market of us middle-aged guys who don't have the money to buy Porsches and Harley Davidsons is huge now, but C64 doesn't cost as much, so that's our favorite pastime.
I don't think that this is it. I think this is one for those guys who think that Sudoku is boring but need something to occupy their mind.
I would agree with that as well. I was just joking.
Because I think that the idea of a programming game for C64 today is not intended to be a game. It's intended just to be an exercise for you to play with.
Okay, I'm happy with that as well.
And this is something that is usually being done for people who are just treating it as a hobby. Nobody's going to try to make money on the C64 game.
No, I'm not so sure about that. There are people selling them, and I'm sure you are aware of the fact that there are C64 clones coming out left and right and center that have been coming out for the past couple of years, and I don't know which one is better. And each and every next one is better than the previous one. There are like 3 or 4 of them right now. Commander X16, and there was that one that was FPGA based that I have at home, etc. So there are 3 or 4 platforms running those games. People are loving them. Some of them are super expensive actually.
Yes, because the production runs are extremely low.
Yeah.
If you want to create something that's going to be as complicated as a clone that needs to support both the old C64 and then the new hardware, and then you need to run it in the run that's going to be 500 units or 1,000 units, this is going to be a hell of expensive.
Yeah, 8-bit guy, YouTube.
Yes.
If you watch, he was heavily involved in the X16 design, so that looks very promising, actually. A lot of people have ordered them. They sold out quickly. So I'm guessing that there's still a market for that. Just based on the fact that all of those got sold in a second. Okay.
Okay. On that thing,
Do we have any other Unixes that we want to mention? Ikes?
No, I'm not going to go into specifics because I don't think that they are interesting when it comes to history.
Okay.
Because what IBM did is they used all the different flavors and the different ideas from the Unix and they made it corporate.
Okay.
They created
still a kick-ass OS.
Yes, but I think that the main thing that IBM did is that they created it so it can be a real-time. It can be a production operating system that you can rely on, and then they basically left it at it. They didn't.
Nothing wrong with that if it works.
Yeah, that's completely okay because I would guess a majority of banks are still running on those.
Yeah, a lot of them are still running.
So
the power-based.
Yes, I would say majority.
Yeah,
I would say majority because since we still need COBOL people.
Yeah, for reasons that are understandable.
Yes.
Not passing understanding.
Yes, so I think that AIX and so on are just going to be things that are going to be with us for a long time.
Can I ask you a question and then we can close the episode?
Yes.
Are you going to file in your CV for the job in Germany to handle the railway-based MS-DOS systems?
It wasn't MS-DOS. It was 3.11 workgroups.
Okay, sorry, I just mentioned
So
one
it's
thing.
broken DOS, basically.
Workgroups worked rather well for me.
Yes, but
yeah.
it was okay. Come on,
Come on.
come on. It was working for you. This is good enough.
Yeah.
Telling it worked is good. Yes, this is one of those things with legacy systems.
Yeah, there are quite a few of them, and they're going to keep on reappearing in much greater, let's say, numbers in the next 10 or 20 years, because these legacy systems are not easily replaceable, just like COBOL that you mentioned, and it's not like somebody's going to invent something out of thin air to run them in some kind of other environment.
But they are already appearing, but you are not considering them legacy. That's the problem.
Okay.
Almost nobody understands or nobody sees that it is completely normal right now to have a server that is running since 2010 on Linux. It's running, I don't know, Ubuntu, whatever, 5, 4, whatever. And, Ubuntu Debian 5 or 4. And it is still in production. And then this computer can be considered ancient. It's 14 years since 2010. And this is just a legacy system, not a legacy system.
Okay.
If we were in 2000, this would be a computer that would be from the 80s. So we need to think about legacy systems and rethink what we are considering legacy systems.
Okay.
So
timeline is important.
Yes, timeline is important, and also the speed in which the technology is moving forward.
Okay.
What is happening is that the technology is slowing down, so legacy suddenly is not legacy. This is something that you can actually upgrade. Because you can.
Yeah. Okay.
And I have a sneaky suspicion that operating systems are going to be continuously slowing down their development.
Okay.
And I think that the main problem is going to be the hardware. So you're going to be just moving the virtual machines from one host to another, especially if a certain company decides to triple the cost,
tenfold the cost,
or 100-fold the cost, and so on. So you are now suddenly in a place where you can actually just move the virtual machines around and press play on different architectures, and this is going to continue. So you're going to have even worse legacy systems.
That sounds like heaven for us. We're going to go deep into our retirement, still earning money for maintaining that sort of stuff.
I know that the oldest machine that I got to replace was 21-year-old.
Okay.
And the oldest machine that was still running, and I didn't replace it because it was running a mission critical thing, was running Windows Server 2003 with the original version of whatever was the SQL version back way then, Cygate's version of the SQL. And if I'm completely sure, I'm not sure if it isn't still in production to this day.
I still have one machine with DOS in production, and the system that I replaced that was ancient for me at the time in 2005 when I replaced it was based on Novel Network. That was a topic that can be a topic of your bashing until the end of time.
This 2003 server that is running still is still running the application in Clipper.
Okay. Clipper apps are not going to go away anytime soon as well.
And it is trying to do it in some sort of networked, shared drive that is being assigned, if you remember the command, to different paths and so on. So this is a hodgepodge job of trying to do a kludge on a patch on a bug, but it is still something that runs in production. So you need, when you're talking about what is a legacy system,
nothing is.
Everything is.
Nothing is and everything is.
Because if you do, be honest to you, if you do a good job of creating a system and configuring and installing something, you have created a legacy system. Because it is going to be left working for years and years. And then you're going to realize that suddenly that, 7 years has passed and you haven't logged in.
Yeah.
And I'm especially talking about things like DHCP servers, DNS servers, and so on.
Yep. I'm fine with that.
Yes. But me too. But the thing is that these are also legacy systems.
Okay.
And they're all based on Unix. So let's finish this thing because I haven't seen a legacy system that was working based on Windows, unless there were either Windows 2000 or NT.
Okay.
Windows 2016 isn't considered legacy. It just releases ugly head every couple of years because it resets itself every update.
I still have a client running 2008 R2 and 2003.
Yes, but those are the ones that don't do auto updates, so they don't.
Yeah, because they haven't had updates for 10 years.
Yes, but the thing is that they are not letting themselves known by just simply going down for no particular reason.
Yeah, that's true. Okay.
So thank you for this one. I'm Yasmin. This is Vedran. This has been the ThatITShow. And see you in the next episode. I honestly have no idea what the episode is going to be about, but see you then.
Okay. Bye.
Bye.